Can you read my screen? Is it okay? Did I on my okay? I on my mic. Okay, if there is anything you turn on the mic and ask, because once I share the screen, I cannot see the what you call the raise your hands also hand also. I cannot see that. So just turn on the mic and then alert me if you have any question. Okay, now we have about 103 students. I think we can start. Another 40 missing. Okay. Anyway, so today the session I will give the overview of the final exam. How many questions are there? Maybe start with that. How many questions are there, and then what is that? And what you have to focus. Okay, for the final exam. Okay. So first you have like a 5 question for the final exam. Why now? Cannot. Mhm. Okay. We have like a 5 question. Number one, number two, number three, number four. Is the overview already given or not by Ayah Hazari? Dia dah bagi tak? How many questions are there? Okay, anyway. So number one actually from Dr. Ilman. He has done the question revision or not, Dr. Ilman?
No, sir.
No, okay. But you can just refer to past year. Not many change from his question. Just refer to past year. Even if we haven't done the didn't do the what to call that revision also sufficient. I mean, if you look at the past year, actually sufficient for you. And then question 2 is actually by me. Then 3 also by me. And 4 and 5 by Ayazari. Okay, you have 5 questions. So plan well to do the question. To do the question, attempt the question. So here, if you see, most of the formula actually provided. Formula provided for this question, for the what you call error calculation, everything in the exam sheet. It's actually behind the mostly actually formulas given. And for my question also, I will let you know which formula actually given, which actually not given. Okay. And Ayah Zahari also not given, I think. ADC1 and anything to do with the type of ADC, this and that actually not given. Okay. Okay. So for ADC, you have to really be careful. ADC actually two types. One actually directly calculating the ADC value for particular temperature or for particular intensity of the sensor. Correct or not? That's actually what I thought. And Ayah Zahari, I believe he thought mainly on the theoretical part of the ADC, how the ADC actually works, types of the ADC. So you have to focus on that for his question. Okay. And make sure you do this question. This one actually like bonus for you. Make sure you do this question properly. Okay. This is also I can consider it's like bonus for you because I already taught in the class this the question. Okay, almost same. And for this question, still can be done, but it's actually quite tricky. This one actually can be done quite tricky, but if you know the step-by-step procedure how to do, you actually can get full marks for this question. My question, so I Zahari question actually like a level complexity level 6 C6 question, so it will be difficult. Okay, it will be difficult. So these two actually will be quite difficult. So just mentally prepare for yourself. Okay, don't always start with question number 1. Okay, if there is any theory, answer the theory part first. After that, come back to the question number 1, 2, 3, then only go to Ayaz Zahari question. Okay, but if there is any question theoretical part here, you just go and do that one first. Okay, this is actually overview of the exam. Any questions so far? Is there any question?
No, sir.
No. Okay. Um, and for my question, actually, there is a formula. Okay. I mean, general formula will be given, but I don't think so NTC actually have in the exam. Okay, no NTC. I discuss about my question only today. Okay, this is actually overview, but I only will discuss question number 2 and 3. So 2 and 3 only I'll discuss today. So question 2 actually like a normal block diagram question. You can, if you see my like our past year, you'll have like a block diagram. Even our test also we had a block diagram, right? From sensor to, like, for example, let's say we have a sensor. Okay, then after sensor, what we will have? Amplifier, signal conditioning, correct or not? Amplifier or filter lah. But mostly we have amplifier. Then we have what? ADC. Okay. Then we have like a controller. But usually sometimes this actually will be combined. Okay. This can be combined if you use like a microprocessor. If let's say there is a built-in ADC, like Elvis lah, Elvis and any other microcontroller nowadays, they have like a built-in ADC. There is no separate ADC, but you still need to know the calculation. Okay, for my question. Then you will have like a IO, okay, digital, and for analog you will have like a DAC. Analog you will have a DAC. Then you will have some output lah, correct or not? Light or anything, light or fan, something like that lah. You'll have like this, correct or not? So you could have seen this general block diagram in my past year question. Okay, in our past year question. Okay, so to do this question, you should you always have to be careful with what is that? What are the sensors actually given to you, and what are the specification? Okay, and usually this is like an analysis question. You won't design a lot, but you still will draw, do some calculation, sketch, explain, correct or not, something like that. And for this question, it's actually LM35. Easy for you, LM35, and this is actually RTD. Okay, LM35 RTD. These two questions I won't tell what are the sensor, because Ayaz Zahari usually won't really, tell the sensor. Ayaz Zahari question, you can see like the sensor which is not taught in the class also can be asked. But don't worry, you should only need to know about the relationship of the input and output, whether it's actually resistance based or direct voltage based. That's all for Ayaz Zahari. And for our case, we will have like a LM35 and RTD only. No NTC, no LDR, I don't know, but NTC don't have. For final exam, no NTC. So even though there is NTC equation, because generally the equation will be given, don't get confused, In the formula sheet, you have NTC equation, don't get confused with the NTC equation. Okay, no NTC question in the final exam, as far as I know. Even if there is you still can do because the equation already given. Okay. Any questions so far?
Doctor,
Yes.
no NTC or no PTC actually?
NTC, PTC, no, both don't have.
Okay.
Okay, no NTC, no PTC. Okay, LM35 RTD, right? Ayaz Zahari question and sensor I won't tell. Okay. But for my question, no LM35 RTD. Even Ayaz Zahari question also no NTC. NTC don't have in the whole exam. Whole exam, no NTC, no PTC. Okay. So you just focus on the LM35 lah, correct or not? LM35 is actually direct either 10 millivolt per degree Celsius or 20 millivolt per degree Celsius. It will be given based on that. Okay. So here you always check. You need to check what are the temperature range. For example, let's say this is actually LM35. you need to check the temperature range. For example, let's say it's actually 5 from 15 degree Celsius. So 5 for degree Celsius means amplifier should be what amplifier should be designed? 5
Differential.
differential. So I believe you are actually good at this one. Don't do any mistake on this part. Differential amplifier because it is non-zero. Correct or not? So what you will do if it is LM35 lamp? So 15 means we 15 degree Celsius is actually 15 times 10 millivolt. You will get like a 0.15 volt, and V5 is actually 5 times 10 milli. You will get like a 0.05 volt. Correct or not? So you'll start everything from there. So and for differential equation, no what to call for this is actually we call it as V out, VM. Okay, V amplifier. No need call V amplifier, V out. Difficult actually, very difficult. V out at 15 you need to calculate, and then V out at what to call 5 is what at V out at 15 should be what if it is a 5 volt reference voltage. Let's say this is still 5 volt reference voltage. At 15 voltage, what you should get?
5.
5. At 5 volt, you should get 5 degrees Celsius. You should get 0 volt. That's actually our intention. So amplifier differential amplifier equation is like this: V out equals to V2 minus V1 times it RF over RI. So this is actually the V2. This is actually the V1. Okay. So we will calculate the RF and RI. And V out should be this actually for the maximum voltage 5. V2 is actually 0.15 minus 0.05 times RF over RI. So what is the RF over RI? 0.1. Huh? It should be 50, right? 50 over 1 RF over RI. So RF could be 500 kilo ohm. RI could be 10 kilo ohm. Okay, right? This is also just revision, for you to don't do any mistake. Huh? Okay. And am I doing any mistake? All okay, right? Calculation mistake. If there is anything, just tell me now. Don't wait until tomorrow, then confuse me. You also confuse, I also confuse. All okay?
Yes.
Okay. So this is actually the what you call normal procedure for you to calculate the RF over RI. If they ask you to draw means you should know how to draw, correct or not? So sketching the differential amplifier, sketch differential amplifier, right? Or they won't tell differential amplifier, they just tell a suitable amplifier for this case. Okay, you should know how to draw it. This is all should be in your head, because you already practiced many times, correct or not? For what? For mini project, for tests and everything. Okay. If you say you cannot remember means you didn't do anything by yourself. That's all. So here you have LM35, and then here you'll design one more voltage divider to set what to call. Sorry. To set what? This is actually came out in your test or quiz. I don't know. R1, R2 to set the minimum voltage. So here you should always have like a 0.05 for this case now. Okay. So if for example, let's say this is actually operating range from 5 to 15. And let's say I tell that calculate let's say that we have like a critical temperature because this is the whole operating range, correct or not? and we have like something like, okay, more than this one I want to have this happen to this one. Let's say temperature more than 7 degrees Celsius, I want to have something to happen, and more than 90 degrees Celsius, sorry, 10 degrees Celsius, I want something to be happen. So let's say T greater than 7 degrees Celsius, I want to something happen, blah blah. Then T is greater than 10 degrees Celsius, I want the output or fan or fan to operate at this percentage of speed or that percentage of speed. Okay, still we consider like a fan easier. Okay, this is actually 7 degrees Celsius mean T more than 7 degrees Celsius. Fan speed like 25%, and here fan speed like 100%. For example, okay. So all this actually will become the critical temperature. 15, 5, 7, and 10 actually will become critical temperature. But 15 and 5 actually doesn't. It's not the difficult thing because it here you will have like a 0 volt, and here you'll have like a 5 volt. So here you'll have, let's say this actually 8-bit means, if this is actually 8-bit means, here you have 255, here you have 0. Correct or not? Um, so you know that this is actually FF for 15 and this is actually 00 for 5 degrees Celsius. But other unrelated temperature you need to calculate now. Okay, calculate the ADC value. So if you want to calculate the ADC value, what is the equation? ADC equation? Output code equals to what? Ingat tak? Times it to n. Here you'll have times it to power of n minus 1. Correct or not? Here you have V reference, right?
In over V reference.
Here you have V, sorry, V in. This should be V in now. V in of the V in of the ADC. Okay, here you have ADC, right? So this is actually V in of the V out of the signal conditioning become V in of the ADC. Don't get confused. Correct, right? This equation. So you what you have to do? You have to calculate. You already have the equation, right? So that's why you will reuse this equation for any temperature. Okay, you'll reuse the equation for any temperature. So V for V 7 degrees Celsius, you calculate the what they call sensor output first. What is that? 0.07. And V 10 degrees Celsius, what is the output? 0.1. Then you have to calculate what? The output of the amplifier voltage. So V out here, it will become like a V2. V2 is actually your 0.07 minus the V1 always fixed with 0.05 times with 50 because the gain just now actually 50. And here also same 0.1 minus 0.05 times with 50. Okay. So for this, it's actually what? How much? For this one? Calculate. 0.02 times 50. How much? 1. 1 or 0.1?
1, sir.
1. 1 volt. And for this one? 2.5.
2.5, sir.
Okay, 2.5. So V reference, let's say 5. Okay, V reference will be given here. Let's say 5. Here actually 5 volt. Also 5 volt. So 0.07 over 5 multiply with 255. This 2 power 8 minus 1 actually 255. You'll get one output code. This is actually for 7 degrees Celsius. For 10 degrees Celsius, you'll repeat the same thing. 0.1 over, sorry, not 0.07, sorry. This is 1. We already calculate here, right? This will 1 over 5. This is the common mistake you do, I do today. This is 2.5. 2 over 5 times, sorry, 2.5 over 5. Okay, you'll get some decimal value here. If they ask in hexa, you have to change to hexa. Or if they ask to change to binary, you just change to binary. Just round off the value. No need to complicate the situation. Okay, and for 0 and for 5 degrees Celsius, we know that this is actually 0, 0. And then for 15 degrees Celsius, no need, because this is actually full scale, correct or not? This is actually 255 in decimal or FF in hexa. Okay. So you see, yeah, regardless what to call temperature here or whatever, you still can the whole thing actually still can be done if you know the whole process and remember the equations. So this equation not given, this equation not given. This equation not given. This is all actually basic equation, correct or not? This is also not given, I think. This equation, okay, not amplifier, LM35 equation. Any question? Ada apa-apa soalan? Tak ada. Okay, for output code, okay, we say that where I say, okay, 25%, 100%, right, the fan. So to control the fan speed 25% and 100%, I should know the ADC value, sorry, DAC value. So here we will calculate the input code for the DAC. Input code for the DAC. So DAC equation is actually like this. Input, sorry. Input code, actually the equation like this, VO, so it's not VO, it's supposed to be V in of the, so V out, like DAC actually have V out, sorry, V out of the DAC, and then Vref, and times with same thing, 2n power of 1. So the n actually depends on the DAC bit system. 8 bit means 8 bit, something like that. Okay. So here you have to see if it is 25% means the V out actually 25%. The V out actually 25%. So let's say here we have like 25% of the 5 over 5, we will multiply with 255 if it is 8 bit now. This is for the case of 25%. How much the input code? And then for the case of 100%, it's actually very direct because it will have like 5 over 5 only, multiply with 255. And other percentage, you have to put the percentage here. Percentage of the voltage, correct or not? Of the voltage, particular voltage, multiply, and then you multiply with what you call that, the normal equation. The other thing is basic. Only here you have to be careful. The percentage actually you use here because the DAC will have like a, this is also will have like a, for example, let's say 8 bit or 10 bit, something like that. And here also you'll have like a reference voltage of 5 volt. So here the maximum voltage will be, I mean minimum to maximum is 0 to 5. V reference 5 means 0 to 5. So 25% means 25% of the particular voltage. 100% means 100% of the particular voltage. That's actually the meaning of the 25% or 100%. So that's why if you want to have like a 25% of the speed means, so the speed actually controlled by the output voltage, right? So I want to have like a 25% of the 5 volt reference. What is the input code should be given in the for the ADC, because controller will give the input code to the ADC DAC, sorry. That's the whole idea. Okay, so this one you calculate later lah. You can calculate. This is actually you'll have like a 255 or FF. All actually thought I just want to revise with you today, because you what to call, you can recall everything. The whole thing actually applicable for any, not only my question and Ayazahari question actually applicable. Somewhere you use this one. For my question, the whole thing you'll use. For Ayazahari question, somewhere you'll use this one. Okay, you cannot run away from this. Okay, anything else if you want to ask before I go to the next part? Sorry, disturbance. Oh, one more thing I forgot. Remember I asked you to what to call. Let's say this is actually we have like a um, like usually in your mini project you have lab view, right? This is actually you have lab view. Actually lab view actually the whole thing now. No lab view. I don't want to confuse. Let's say you have like a display here, because lab view actually you have here the controller with ADC and everything actually the lab view. Maybe this is actually the lab view part for the mini project. Yeah, tulisan teruk lah. Sorry ya. It's very high. Lab view. Okay, you want to display the temperature. If you want to display the temperature here, you have to display the temperature here. We did some equation that day. Remember, we want to change this input V here. We want to get the temperature. So we need to produce the equation, correct or not? For the lab view to get back the temperature for the particular, because here what you get actually directly the voltage only 0 to 5 only you'll get. But 0 means we know 5, 15 means we know 5 means we know 15, 0 means we know 5. But others actually we don't know, correct or not? So that's why if you want to get the equation to correctly transform this particular temperature, which is already translated to voltage, this voltage line we want to translate back to the temperature, we need to have the equation. So that's why we use the y equals to mx plus c. If you remember that day, we used this equation to get the relationship between the temperature and voltage. So here, if I make the temperature as, this is V, this is T, V is actually V is where? V is 0 to 5. The temperature actually 5 to 15. Okay. We form the equation, remember? So we have like, this is actually T equals to M is what? M is 10 over 5. Betul kan? 10 over 5 V plus intercept already have, we have 5. So T equals to 2V plus 5. So this is also you should know. Okay. So this is actually for question 2 and the whole EI, not only for question 2 itself. The whole thing that you see for this discussion is actually not only applicable for EI, you can actually use for this whole exam. Okay, dah. Any questions so far? Ada soalan?
No, sir.
Wait, wait for the azan finish first. Okay, just done. We can continue back. Um, so for the second question, I believe I mentioned to you before, we will have one question from here. The RTD, where the equation will be given to you something like this. Transfer function of the RTD will be given to you something like this, where the alpha and alpha will be given, two alphas will be given, and you need to calculate the something called self-fitting error. Sensitivity first, you'll calculate the sensitivity. dr over dt, the differential of this equation actually sensitivity, known as a sensitivity. So you'll get the sensitivity first for this question. Okay, if you remember. So when the equation given, you just differentiate the equation dr over dt, and that particular value that you got is actually sensitivity. This is actually the first thing I already taught you last time. And There is one more topic under this one, which is known as a self-heating error based on the power dissipation. Okay, because resistor, you know, right, when it's actually when it's actually there is an increase of the current inside the resistance, you will have like some error based on the power dissipated. Some of the energy actually will be lost through the power. So when the I increase, you will have like some error there. Okay, because it has its own self-heating. RTD actually resistor, correct or not? It sends some what is that, some temperature, and it shows some difference. At the same time, due to the current flow through the RTD, there is also a phenomenon called as a self-heating. So self-heating is actually you cannot avoid, correct or not? When there is a I current flow through the R, it will have like a self-heating. That's actually the basic idea lah, okay, of the self-heating error. Okay, so this is actually known as error because unwanted heat. We only want to sense the some particular temperature, but there is also like internal temperature that arise from the resistor, current flow through from the resistor. Okay, so this is actually done, correct or not? You already done the sensitivity, and after that, um, there could be a question asked like this: calculate the maximum current that can flow through the RTD. So this delta T is actually known as the delta T. This equation actually will be given in the exam. This equation actually will be given in the exam. This is power dissipated from the RTD. Power means what? I square R. Okay, I square R. And the delta is actually known as the heat dissipation constant. Okay, and this delta T is actually the self-heating error. This delta T is actually self-heating error. Okay, equation will be given like this. Okay, equation will be given like this. But at the end of the day, you will calculate the I. This is actually what we want to calculate. Because what they asked to calculate, they asked to calculate the R that can flow through the RTD, so that the delta T, the error, is less than 0.1. The temperature error less than 0.1. Okay. So what we will do, we will, all this actually will be given. Delta will be given to you. Delta T will be given to you. Okay, this delta will be given. Heat dissipation constant will be given to you. Delta T actually, the error also will be given to you. Okay. The only thing you need to calculate is actually the I. So substituting this one here, you will have like at last you'll have like a I equals to, for this case I equals to square root of 0.01 over R. Okay, so delta, for example, let's say here is actually given like this. This is also 0.1, and the error also 0.1. So 0.1 times 0.1, you have like 0.01, which is equals to I square R. PD we already changed to I square R, and I equals to, at last you'll have like this I equals to square root of 0.01 over R. Now the issue is you have like an operating range for this one. This is actually from 0 to 100 degrees Celsius. So based on this equation, okay, you will substitute 0 here. You calculate R for 0 degrees Celsius. You will calculate, substitute 100 here at the T to get the R for 100 degrees Celsius. So there you have like a 2R for 0 degrees Celsius and 100 degrees Celsius. What are the R? So here you have like a 100 ohm, and this is already done that day, 100 ohm and 119.75 ohm. So here you'll get two current, and we will choose the lowest of them, because if it is greater than this one, then it will be more than the limitation of this one. We want to have less than 0.1. If you choose more than this, then it will get greater than 0.1. So it doesn't satisfy the question. This is one question you must do, because equation already given to you, and the concept, don't forget that dr over dt is actually the sensitivity. The equation not going to be the same, it will be different. Just what to call, don't get panic. Okay, don't get panic and do as much as can as in a normal way. Okay.
So the alpha value will given.
Which one?
Alpha value.
Okay, alpha will be given lah.
Oh, okay, okay.
This is alpha here. I didn't give alpha means you cannot do the question.
All right.
Okay, everything will be given, just that you don't get panic. Even this equation also given to you in the back sheet of the appendix of the what to call the final exam. You just don't get panic. But this is actually will sambung dengan what to call that bitstone later. I believe I taught the bitstone. I think I taught in a different RTD question. Okay, so once you get 2R there, okay, RTD you'll put at the bottom. RTD will put at the bottom. So this is actually the Wheatstone bridge. Okay, regardless what equation given to you for the RTD, you'll put RTD here. Correct or not? You'll put the RTD here. And this is a configuration of the Wheatstone bridge. It's actually act like a two combination of two what to call two voltage divider. Two voltage divider. So um, the R will be given to you. R1, R2, R3 will be given to you. The choice of maybe they give like 100K or 10K, whatever. You just put there. Okay. Then RTD will be here. You need to know how to draw the Wheatstone bridge. Okay. Then you will have what to call that. What is that? Apa benda tu? You will calculate the RTD value, right, for both temperature just now. For example, let's say here, from 0 to 100, you have like a uh, 90, forgot, 100 to 109, right? 119, right? So that actually will become your R2 RTD value for minimum and maximum. Okay, the resistance of the RTD for minimum and maximum operating range, you should know. Then you calculate as usual, regardless what are the temperature, what are the resistance actually given to you. So don't get panic. Wheatstone bridge, I told you that day, but I didn't mention in which question actually come out. So this question actually come out. So just do it calmly, okay? Do it calmly, don't get panic. Okay, so you'll calculate VA minus VB. Maybe you didn't get 0, but just calculate. VA you'll have like this actually will become like a 2.5 because same resistance value. If let's say 10K actually get like a 2.5. And here you will have like, what is that? VA minus VB, maybe you have like a different value apart from this one. Okay, I'm sorry, VA. You will get VA actually different for one resistance and VA actually different for another resistance. Then you just minus to get the output of the Wheatstone bridge. It stop until here only. You won't have it won't go to next stage, like signal conditioning and then signal conditioning, ADC, all actually won't have, because this is actually too much for this question. Because you'll do this part first, correct or not, and then sambung dengan Wheatstone bridge actually quite complicated the question. Okay, yeah, for my question only LM35 and RTD. I already tell because I think very long break after the Chinese New Year, correct or not? Chinese New Year and the study week, okay, this and that, and you already passed almost like 2 weeks for the exam, right? This is actually going to be third week, right? Third week, right? Third or
Third.
second week? Third week. I believe you forget many things, so just I hope this what I call the revision help you to do the final exam in a very best way. So don't get panic if Dr. Ilman didn't unable to do what to call the revision class. You still can do, just refer to the past year questions. Last 2 year past year question is sufficient for you to do the Dr. Ilman question. Anything else you want to ask? Ada apa-apa? Clear? Wait, 107 only lah. Oh my god. Exam easy or not, doctor? If you study easy, if you're not studying difficult. Okay. Okay. I think I better upload now lah, because I forgot sometimes. Wait, give me some time. I put in the Telegram first. Later, if I have time, means I'll put in desktop revision 2. This is 3. This one,
Doktor,
yes.
yang IP ADC tadi, yang VO over VREF tu ADC atau DAC?
Apa benda you tanya tu? Sekejap.
Okay.
Nanti saya lupa ni pula. I upload ni dulu. Nanti saya lupa pula. Revision 2. I terus masuk dalam Telegram. Tak payah tunggu. My God, too much things. Desktop. Okay, dah masuk yang revision punya notes tadi. Okay, apa soalan you?
Ya, tadi doktor ada bagi input ADC punya formula VO over
Okay.
VREF. Tu
Okay,
ADC atau DAC?
Tunggu. This dua look same only, no. Because you see, ADC and DAC, this is the equation lah for DAC. Correct or not? Tapi kita nak cari input code kan, so benda ni akan pergi sini, VREF akan masuk sini, so dia akan nampak sama. Just that this is actually V out, that one actually V in or VREF kan. Dia untuk ADC dia akan jadi input code V out or VREF, tu saja. Kalau benda ni pergi sini. Kan?
Okay.
Anything else, Veda? There is something in the chat box. Will there be obviously we'll have my part. My part, I consider like the what they call the Wheatstone actually all theory because you have to remember, correct or not? If my part actually have theory question also maximum 4 marks, it won't be more than 4 marks. And then you just write something, I'll give marks. Okay. I'll ask to like explain, correct or not? If there is a question, but I don't think so. I have theory question for what is that? For this final exam. Theory also will have.
Doctor, for your part, can refer to the past years also, Doctor.
Can past year actually can refer for my part because my part past year actually will give like a what to call that better understanding, brush up your skill, correct or not? On doing the calculation, especially question 2 and 3 lah past year. 2, 3, 4, not design question, 2, 3, 4. If it is not design question, it will be helpful past year. Because past year question mainly if there is something related to what to call this block diagram question like this, correct or not? This obviously will be helpful, no? But this one is actually new. This is actually new. This is not in the past year. This is actually freshly for you, like what you call exam gift from me. So this one don't have in the past year. This one don't have in the past year. This is the first time I'm actually giving the question something like this. Okay. Past year, past year, that 2 past year actually enough. 2023 and 2024. No need many. If you want to practice, if you have time means you can go for 2022, but you don't time means just look at the 2 past year enough. Yes. What do you ask, Samuel?
No, just thank you, Doctor.
Okay.
Doctor.
Yep.
What about Dr. Zahari? Can we refer to the past year, especially the last 2 years?
Ayat Zahari question. you just refer to his notes, his exercise, sufficient. But if you look at the past year, still okay, because as I told you, you see, yeah, the whole idea is to design what to call that amplifier based on one temperature. That actually will be helpful now. But specifically for his question, the latest note he shared in the what to call the last class actually very important if you ask me. And that could be something like different. Any attenuation questions gain less than this time? What is that actually? I tak faham lah, Lim Kaizi. Any attenuation questions? Or RF or RI? Apa maksud tu? I don't think so attenuation question lah. If there is attenuation question also not from me. Because gain less than 1 is actually attenuation, right? My question is actually purpose to what they call accommodate the ADC, so you have to amplify, you cannot attenuate. I don't know, I Zahari question if there is any attenuation. Or RFRI, I don't understand. What is that? Dia sendiri tak tahu kot apa yang dia tanya tu. Tak mau tanya. Anything else? Boleh ya? You still can contact me if there is any major issue that you cannot understand. If we have like another 2 days, okay. I believe, okay, because I saw possible questions in question sample somewhere, but probably maybe his part, not my part. Okay, if there is nothing else, I think that's all from me. Good luck. Can you share also the ADC class notes? I didn't share yet. Wait. Any? Maybe I didn't share that because this is actually from the last class, right? Anything else missing that I didn't share yet? Anything missing, me just let me know. I'll share the notes. Later I'll check the e-learning. Okay, anyway, but this is actually all the important one I shared today. Why not? Very okay. Uploading. Anything else? Okay, I think that's all. No more noise from you. Okay. Thanks for attending the class. Please share the details with your absentees. Okay. Maybe they have something else to do. Maybe they tired after today. They had the exam, right? Some of them actually had the exam, I think. Maybe they tired after the exam, sleeping. Correct or not? Just share the notes with them. Notes actually, I already share the details. Any details that you think important, share with them. Okay. Good luck for the final exam. Okay. Just prepare well, rest well. Eat something before you come to the exam. Especially sugars. Okay, sugars or chocolate. Eat something before you come to the exam. Don't come with the empty stomach, because a lot of energy will be needed for our exam. Okay. Thank you.
Thank you, Doctor.
Thank you, Doctor.